Okay, looking through this. Okay, I don't need to explain all of this because we'll have opportunities to talk about it. And this should give you a good shot. Okay. The one that I want to talk about is number 4 here. So number 4 says, which of the following exhibit the strongest London dispersion forces? Okay, so the implication here is that you already know that they're all London dispersion. You're trying to figure out which London dispersion is strongest. Well, we talked about in class today, London dispersion is stronger when there's more surface area to induce a dipole. So when we talked about pentane, we said that this thing, if all the electrons got on one side, you'd have a slight negative with a slight positive on the bottom, which would induce a dipole in the second one with the electrons jumping up to the top, giving it a slight negative, slight positive on the bottom, and then we could have an attraction between them. Right. So we talked about that. Well, if I have a larger molecule, then there is more surface area with which it can induce dipoles, and so the attraction is greater. So with London dispersion, things that make it stronger are 1, being a bigger molecule. 2, let's say you have 2 molecules that are the same size in terms of like number of carbons and stuff. Then I would look at how, I like the word stackable. I would look at the stackability of the molecule, if that makes sense. So, sorry, just rearranging. So, for example, if I had 1, 2, 3, 4, and 1, 2, 3, 4, well, if I'm trying to create surface area contact to induce dipoles, this molecule is going to be much better at it than like this molecule, right? And so these are the same size, so then I would look at stackability, and this guy is much more stackable. So I think for this problem, I mean, they're all just diatomic molecules except for the helium. But so you're pretty much just going to be looking at size. But yeah, so that'll help you with figuring out the strength of London dispersion forces. Okay, let me just make sure this one just asks for dominant intermolecular force, dominant intermolecular force, dominant intermolecular force. This one asks for what's the strongest ion dipole. I would recommend, now they're all in aqueous solution, which just means that they're in water. So your dipole is just going to be water. So then your ion are these things, right? Remember that. Remember Coulomb's law. And if you remember Coulomb's law, looking at if charge goes up, the strength goes up. If charges are the same, then the smaller molecule can be closer together. So that one's the best. So just some things to think about for 10 and for 11. Talks about Teflon. I would just let you try and figure that one out on your own. So I hope this has been useful. I hope that some of you listen to it. Again, you're going to hear a lot of the exact same stuff in class on Tuesday, but hopefully this will help it stick. If not, whatever, if you don't want to watch it, it's fine. It was just a waste of my time and not a waste of both of our times. But anyway, thanks guys. Go Cougs.